beginning of the section till now. He has done some like that on Saturday. I was there. So let him finish. Usually those non-metals and metals, they are volatile. You usually forget them. Then by 10, by God's grace, I'll return to round up the Jamb club for 2025 section and release you to go and succeed. So please, let's stay in class. Do go and start buying pure water up and down.
How are we not going to know?
Okay, good morning. Yeah. um, Okay, yeah, let's just quickly look at some, like, how do we call it? A fine tune or like questions generally on what we have done so far. Can I have a quiet, please? Yeah, Ronke Uncle. Or Sharimo. Okay. I know you guys have a lot to say to your friends and stuff like that. But let's just take these few minutes to do something. Okay, now see, let's just take this now. Let's see. Now, this will help some of you to find some what you have known, and this can also help to perfect some of the things you've done before. So now take some of the questions related to acid and base. I'll just be taking like approximately like five questions from each of these topics you have done from your remix. So I'll try and move as fast as possible. Let's take this question. Question one. And this question one is under the rates of chemical reaction. Now, question one is under the rates of chemical reaction. Now, being that frequency, don't get tired. Now, this can be a difference between 299 and 300, you know. So let's take this now. In the equation below, stay in that frequency. I'll be missing you guys anyway. So you have this now. In the equation below, we have Na2S2O3. In the equation below, Na2S2O3 plus HCl. Na2S2O3, not SO3, Na2S2O3. Na2S2O3 plus HCl. Na2S2O3 plus HCl. Note that the HCl is aqueous. The two of them are aqueous. So you also have this to be aqueous. Then the product we are having is 2NaCl. 2NaCl plus H2O plus SO2 plus S, which is sulfur. Now the question is, which of the following will introduce the greatest increase in the rate of chemical reaction? Note, greatest. Which of the following will introduce the greatest increase in the rate of chemical reaction? The greatest. If you need to underline that. Which of the following will introduce the greatest increase in the rates of reaction? Number one, we have option A, decrease in the temperature and increase in the concentration of the reactants. Decrease in temperature and increase in the concentration of the reactants. Note we are looking for the greatest. Please, I tell students when you get to exam hall, take your time to understand the question before you jump into conclusion. WAEC is quite different from UTM. Sometimes all the options can even look alike, except one that is only meant for someone that is high on pure water. But there are some that are always very clear. So take time to understand the question. And this is option B. We have an increase in temperature, and a decrease in the concentration of the reactants. An increase in temperature and a decrease in the concentration of the reactants. An increase in temperature and a decrease in the concentration of the reactant. Then option C, an increase in temperature, an increase in temperature, and an increase in concentration of the reactants. So which means increase in temperature, increase in concentration of the reactants. Then option D, a decrease in volume, a decrease in volume, and an increase in the pressure of the reactants. Okay, so I'm going to try as much as possible to run into a little bit of explanation while we look at those questions, because we know that when you have your question, there might not be direct statement like this, but they are still going to be under the same scope. You understand? Not direct question, but the same scope. Now, let's look at this now. If you're in this class, if you're following the frequency of the class as you're taking the spaghetti, now you understand that there are two factors that affect the rate of chemical reaction. Okay? Two factors. Number one is catalyst, right? And what does the catalyst affect? Activation. So you can either lower or what? Increase. Then what's the second factor? What do they affect? Frequency of, I love that. That's the word. Frequency of collision. What's it on? So when we decrease the rate of chemical reaction, when the frequency of collision was decreased, when we increase the rate of chemical reaction, when the frequency of collision is what? Increased. So when you look at that option, we are looking which of them what? They be the greatest, right? So if you look at what's the best option there? Option C, increase in what? Temperature and increase in the what? Concentration of the reaction. Okay, let's take of the reactant, yeah. Let's take this question. Just I said I'm looking at two questions each. Looking at two questions each. Oh, let's say 5 before I move to the next topic. Okay. Now, this one says, in the preparation of oxygen, all right. Like I said, let your attention be under this voice. In the preparation of oxygen by eating KClO3, in the preparation of preparation of oxygen by eating what? KClO3. KClO3. Okay. In the presence of MnO2, in the preparation of oxygen by eating KClO3, in the presence of what? MnO2, comma, only moderate heat is needed. Only moderate heat is needed. Only moderate heat is needed. Only moderate heat is needed because the catalyst, see, in fact, if you look at audio story that was acted there, this last statement is the key word there. Now that because the catalyst acts by, so when we look at the preparation of oxygen, if I have KClO3 decomposing to give us KCl plus O2, right? I think that would be balanced equation, right? Then what do we use MnO2 for? Catalyst. What kind of catalyst? Positive what? Catalyst. So we now said option A, increase the surface area of the reactant. Option A, increase the surface area of the reactants. Then option B, you have increase the rate of reaction. Increase the rate of reaction. Then option C, lowering the energy barrier of reaction. Lowering the energy barrier of reaction. Lowering the energy barrier of what? Reaction. Then option D, right? Is it option D? Okay, option D, lowering the pressure of the reaction. Lowering the pressure of the reaction. Now, when you look at that question, you tell me understand that a lot of people, page 55. Okay. Now, looking at that question, you tell me understand that a lot of students will be looking forward to activation energy, right? But in that option, was there activation energy there? So what do we have there? Increase the what? Mahidaba. By reducing what? The energy what? Barrier. Hey, Don't do your loan. Please don't be average. The energy barrier is the activation energy. So you can write under that the question there. The energy barrier is the same as what? Activation energy. So when you remember when we were drawing that graph, you have something like this, right? The reactant, then climbing a what? A barrier. This is the barrier. What do we call this barrier here? Activation energy. So UTM might not use activation energy because they know, see, they want to screen. Yeah. Some don't know. Fine. Then they are still trying to screen part of those that still know. So you have to be very careful. Please read the question. Take your time. Read question. Understand the question. Understand the question. I've seen students attempt 35 and they still do very well. I've seen students, I remember one year why like that. See some students coming out solving the whole 10 question in mathematics and they still have C4. And still some they still solve like 5, 6 and they still have A1. Oh, yeah. But I'm not saying that leave questions untouched, but I'm saying that understand every bit of the question before you jump into conclusion. So you know that one, why is increasing the rate of reaction not valid? Because that is not peculiar to the function of what? Catalyst only. The major function of catalyst is what? To reduce the barrier. And the barrier is what? Activation energy. Any reaction that is influenced by light is known as what? That's photolytic, right? A photolytic reaction. Can you give some examples? That's all I'm getting right now. Okay, photosynthesis, a photochemical reaction. But know that substitution reaction of what? Methane, I mean. So you have CH4 reacting with what? Chlorine. So this will then go what? CH3Cl plus what? ACl. And it takes the presence of what? Ultraviolet what? Light. Same thing as the sunlight. Now, if you are asked the question, what is the final product for the complete reaction? Tetrachloromethane. So the reaction is what? A photolytic what? Reaction. How about German for? Stay in that frequency. So let me just take one more question because most of the questions here are repeated and I think they are all under. Okay, let me just take this last one. The equation, A will be what shows relationship between concentration and the rate of chemical reaction? What shows the relationship between the rate of reaction and concentration? What shows, one will say zero order, first order, second. That's what? The rate order. Hey, something like aluminum. Yeah, let's write this now. In the equation below, in the equation below, in the equation below, in the equation below, right? X plus Y produce Z. In the equation below, X plus Y produce what? Z. The rate order, I write in the equation, then you write the rate order is T to K. You have T equals to K. Then concentration of X raised to 0 and concentration of Y raised to the power of 2. So that's the rate order for the equation. Then the question now says the overall order of reaction. If you have this equation, the overall order of reaction, the overall order of reaction is option A, 0, option B, 1, option C, 2, then option D, we have 3. So what's the answer to that? The answer is what? 3. The answer is what? 2. How come? Because no, the rate order of the, how do you get the total rate order? By adding everything together, right? So 2 plus 0, you have what? 2. When the rate order is 0, what does that mean? It means change in concentration does not affect the rate of what? Reaction. So with respect to X, what's the rate order? 0. With respect to y, what's the rate order? 2. Then the overall is what? 2. They are staying. Just one question, then it's always one, I've been saying. Okay, let's take this now. I'm just trying to look at random. We have the highest rate of production of CO2. The highest rate, are you going this way? The highest rate of production of CO2. When acid reacts with trioxocarbonate, what is the name of the gas liberated? CO2. When ammonium salt reacts with a base, what's the name of the salt liberated? Ammonia. Be in that frequency. Now, I have this and say the highest rate of production of carbon 4 oxide, the highest rate of production of carbon 4 oxide can be achieved. The highest rate of production of carbon 4 oxide can be achieved using option A. Using option A, 0.05. Option A is 0.05 mole per dm cube HCl. 0.05 mole per dm cube HCl and 5 gram powder of CaCO3. So option A is 0.05 mole per dm cube of HCl and 5 gram of powdered CaCO3. Option B, we have 0.05 mole per dm cube of HCl and 5 gram of lump CaCO3. By now, you know there are two factors they are considering here, right? What's the two factors? Concentration and surface area. Then option C, we have 0.10 mole per dm cube of HCl. Then you have 5 gram lump, with 5 gram lump CaCO3. Then option D, we have 0.025, that's 0.025 mole per dm cube of HCl and 5 gram powder and 5 gram powder of CaCO3. So in this case now, what's going to be the best answer there? The one fastest, right? That's why 0.10, 0.05. Okay. So we have option, what is option C? Okay, which one have the highest concentration? Why did I call option C? Oh, sorry, it's meant to be powder. So the fact that it's powder makes it to what? Option C. Thank you. So assuming you have it to be lump, the answer there will be what? Option what? A. Yeah, very good. Okay, Akorede. Okay, Akorede, your mom is, I think she said she thinks Ayodele. Akorede Ayodele. Yeah, your mom is downstairs. Okay, let's move very fast. Please stay in that frequency. I'm going to go to non-metals now. So I want to pick, what's it called? Non-metals. So here we have the first non-metal we have here is going to be hydrogen, oxygen, and what? Then can I actually normal freestyle. The hydrogen will be oxygen and what? Carbon. I know you're about to sleep. So you have the hydrogen, the oxygen, and what? Carbon. Oh, yeah, go. How many oxide of carbon do we have? How many oxide? How many oxide? 2, which is what? CO2 and what? CO. Hey, okay. We have CO2 and what? CO, Abby. Which of them is the most dangerous? CO is dangerous, right? What does it compete with? Hemoglobin. Okay. Now, when you now look at that carbon, how many allotrope of carbon do we have? That's carbon 60, Carbon 70, abi? Carbon 60, graphite and diamond. Abi? Those are the two allotropes, right? How many isotopes? 3. Carbon what? 14, carbon 13, and carbon 12, abi? Okay. Then the amorphous. What are the amorphous? What is the meaning of amorphous? Shapeless. In other words, we say non-crystalline, right? Then for oxygen, mostly they'll talk about oxide. Hey, they'll talk about what? Oxide. Hope you are prepared. How is air separated to get oxygen? What are the 3 methods to get oxygen from air? Nisu. Number 1, we remove what? CO2. Then number 2, we do what? Liquefy. At what temperature does air liquefy? Minus 200. Why does it lead to a sudden expansion? No, when you're trying to liquefy air, you pass it through a tight aperture, right? Then this tight aperture leads to a sudden expansion. What's the purpose of the sudden expansion? To make it what? Liquefy faster. That's what. To make it liquefy faster. After you have the liquid, okay, then what do? You do what? Fractional distillation. What's the boiling point of oxygen? Minus 186. Then nitrogen. Minus 196 and minus 183. Yeah, oxygen is minus 183. Oh, but those are some of the key things you have to understand. Then for carbon, which of them conducts electricity? Graphite, right? Then does diamond conduct? Which of them conduct it? Alaja, which of them conduct it? They both conduct what? It. And you will say that diamond is 6 times then, yeah, than copper, right? In terms of conductivity. Yes, I believe. What's the shape of, what's the color of diamond? Colorless, right? But when there's impurity, why is diamond used for jewelries? High refractive index. High refractive index. Yeah, it shines when you polish it, right? So let's say some of this question. Question 1. That's under, it's going to be under oxygen, hydrogen, and carbon. So I'll try and be in the 2000 series. I think those are way more closer to your syllabus. So let's take this. Okay, let's take this now. Carbon exists naturally in the combined state as carbon exists naturally in the combined state. Carbon exists naturally in the combined state as we have option A, that's exists naturally in combined state as option A, diamond. Option B, we have coal. Option C, we have wood. And option D, we have graphite. So what's going to be the answer there? The answer is what? I'll take the question again. Carbon exists naturally in combined states. In combined states. So the answer is what? Jogba Mike. In combined state, what will be the answer? Coal is an amorphous of carbon. Koye. Which means it is made up of only carbon. Hey. So the answer there is wood. Because wood is made up of cellulose. That's C6H12O6. Because, yeah, natural combined. So when you look at coal, coal is not in combined state. How do you represent coal? We use what? Carbon, C. It is not combined. Oh yeah, diamond, use C to represent diamond. So the one you have naturally in combined state, there is what? Wood. That's how it. Now remember we said hydrogen, 40% of hydrogen produced, what is it used for? Ammonia, evaporation. And 20% is for what? So the most important use of hydrogen is in the production of what? Ammonia. And what's the most abundant element in the universe? Hydrogen. Well, let's take this question. That's a question, very important question. Okay, right. The oxide The oxide, are you writing? The oxide that remains unchanged. Are we there? That's the question. I mean, I'm seeing hydrogen now. The oxide that remains unchanged, the oxide that what remains unchanged when combined with hydrogen. The oxide that remains what unchanged when what combined with what hydrogen is, then we have option A. The oxide that remains unchanged when combined with what hydrogen is option A. We have copper oxide, that's CuO. Then you have iron oxide, Fe2O3, Fe2O3. Then we have lead oxide, that's PbO. I think there's a mistake here. Then we have zinc oxide. Now we look at the question. What's the question there? Which of the following does not what? Remains what? Unchanged when what? Combined with what? Hydrogen. You know, normally if you have a reaction, like you have copper oxide plus hydrogen. Now the hydrogen is going to act as a reducing agent here, collecting the oxygen to become what? H2O. Then we have what? Copper, right? So the question is there is which of them, you know what? Now write this under it, right under the question. The answer is what? Zinc oxide. And what's the reason? It can be what? Because it's in position in electrochemical series high up there. Do you understand? So how many questions do you have there now? I think 2, right? Okay. Now, zinc is larger than lead. That's why it will be difficult for hydrogen to react with zinc. Do you get it? Go of the position. Now, the flame we use hydrogen for, we call it, what's the name of that flame? That oxy what? No, we have oxyethylene flame. That's different. But when you use hydrogen, what do you call it? Oxyhydrogen flame. What's the temperature? 2,900. What is it used for? Used for cutting metals. Not for. Okay, I think I'll just take this last question, then we'll just proceed. Which of the following will liberate hydrogen from dilute sulfuric acid? Which of the following will liberate hydrogen from dilute sulfuric acid? No, the formula for sulfuric acid is what? H2S4. SO4. So which of the following will liberate what? Hydrogen from dilute sulfuric acid. So remember that when acid reacts with metals, what is liberated? How do you test for hydrogen? Gives a pop sound. Oxygen, rekindles what? A glowing flint. Now, calling option A, we have magnesium, Mg. Option A, we have magnesium. Option A, we have magnesium. Option B, we have copper. Option B, we have copper. Option C, we have gold. Option C, we have gold. Then option D, we have lead. So what's going to be the answer there? Magnesium. Why? Is higher than what? Hydrogen in electrochemical series. What are the mixtures of gas you find in producer gas? Producer gas. Yeah, CO and what? Nitrogen, right? But in water gas, what do you have? CO and what? H2. The process for the production of hydrogen, what do you call it? Bosch process. Sulfur. Ammonia. Then what's the, I always repeat the drying. Apart from ammonia, what's the major drying agent we use? H2 what? SO4. What's the difference between drying and dehydrating? Two of them is removal of water. So what's the main difference? Okay, drying does not change the chemical formula. Then dehydrating, we change the what? Chemical formula. Okay, when sulfuric acid reacts with ethanol, is it? It was not ethanol. When H2SO4 react with glucose, We call it what? Sugar what? Charcoal. That's carbon. So that's the purest form of what? Charcoal. Okay, now let's go to chlorine. Chlorine. I'm moving very fast. All of time. Now we have chlorine, nitrogen, and we have sulfur. Of the halogen family, which of them is the most reactive? Fluorine is the most reactive, right? Yes, the most reactive. So I'm going to take like, say, 10 questions here. So that's this question. Sulfur exists in 6 forms in the solid state. Sulfur exists in 6 forms in the solid state. Sulfur exists in 6 forms in the solid state. Sulfur exists in 6 forms in the solid state. How many type of tin do we have? The what? Yeah, the gray, the white, and the what? And the what? Brittle tin. Which of them is the most stable? Brittle. What do I call that nature? Polymorphism. No, it's not isomerism. That one is called polymorphism. Yeah, but take this question. Sulfur exists in 6 forms. Sulfur exists in what? 6 forms. Yeah, sit up. Sulfur exists in what? 6 forms in the solid state. This property is known as option A. This property is known as option A, isomerism. Option A, isomerism. Option B, allotropy. Option C, isotropy. Then option D, isomorphism. Sulfur exists in 6 forms in the solid state. So what's the answer to that? Allotropy. Now take this question now. Which of the following gases will rekindle a brightly glowing splint? Which of the following gases will rekindle a brightly? Yeah, it's like when the light is about to go off and you bring the gas, yeah, it makes it burn faster. So there are 2 gases that can do that, right? But let's say they ask you this question now. Which of these gases can rekindle a light, what is called glowing splint? Not brightly colored. That would be what? Oxygen. Why do we need the bright colored? The bright light. Why must the light be bright? No, the question is, which of the glowing gases will kindle a brightly glowing splint? Brightly. Hey, but why they put that brightly there is that, what's the formula for laughing gas? N2O. So the reason why it is brightly, so that the light can split it into 2. So we have nitrogen and what? Oxygen. So this oxygen will now do the process of what? Rekindling what? The glowing splint. That's why I need what? The brightly colored. What's here? The answer there is N2O. So N2O and oxygen. Well, how does N2O smells? That's a sweet smell. Malafish, painful. NO2. No. 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 It's only laughing gas. And do people actually laugh when they inhale? Now, this is actually, the gas is known to cause the tendency of laughing. Yeah, exactly. So you have the very high tendency. And I think people can last for like 6 hours. Yeah. Yeah, exactly. No, okay, let's leave that part. Yeah, that is when it's used under precise, when it's not inhaled in excess. In that case, it will be in the liquid form, injected into the parts, and it is used. No. It's the gas that instigates that process. I think that one is to be in the liquid form. Yes, I Kweli. Okay, we'll get to there. Right, this now. The brown film given off when triazonitrate 5 acid is heated. The brown films given off when triazonitrate 5 acid is heated. Stay in that frequency. The brown film given off when triazonitrate 5 acid is heated consists of. So we are trying to look at the decomposition of triazonitrate 5 acid. Stay in that frequency. the decomposition of triazonitrate 5 acid. That's HNO3, right? Okay, before we even go to the option, normally when triazonitrate decompose, group 1, what do they give us? That's a nitrite, Abby. Now listen, I said, if what I'm saying you don't understand, and person beside you understand, tap into his grace. But here, ask questions. Ask questions. The reason why some people are facing challenges because they refuse to ask. You come to class, 2 hours class, and you didn't learn anything. And others are answering questions, and you have the audacity to stand up and go home, and you can sleep. Actually, well. So now this is another grace to just rectify something there. So now when triazonitrate are decomposing, that's NO3, Abi. If it's group 1, what will be formed? Nitrite, Abi. And what? And oxygen. Then below the group 1 down to copper, what do we have? The oxide, NO2, and what? Oxygen, right? So now, if you look at HNO3, if this compound is ethyl, what will it give us? Oxide. What's the oxide of hydrogen? That's H2O plus NO2 plus what? O2. What's the color of NO2? Brown. NO2 is brown in color. And let's look at this now. The brown film given off when triazonitrate 5 acid is heated consists of option A, NO2 and O2. Option A, NO2 and O2. Option B, H2O and NO2. H2O and NO2. Option C, NO2, O2 and H2O. Option C, NO2, O2 and what? H2O. Then option D, NO, NO2 and H2O. Option D, we have what? Oh, remove. NO, NO2 and so what's going to be the answer there? Option what? C. NO2, O2 and what? I think when someone was asking me this question, they asked them, I think was it our mock or something. They said, which of the following triazonitrate will not release oxygen on eating? What will be the answer? Got question I could do down. Which of the following triazonitrates will not, hey, me. Which of the following triazonitrate will not release what? Oxygen. What will be the answer? I'm not giving options. So. Which of the following triazonitrates will not release oxygen? So, KNO3 will give you nitrite and oxygen. Now, which of the triazonitrates, will not release oxygen? Ammonium what? So nitrates. That is used for production of what? N2O and what? Water. See, you have to be they know that all of them give oxygen. And some of you are prepared for that. This one will give oxide and metal. And look at where they came from. So write the question. Or just write notes. Only ammonium triazonitrate does not release oxygen on eating. Please, you have to be very flexible. Chemistry is not one direction. Surely. Hold that back. Okay, let's take this question before we go into a little bit of thermodynamics. That's little calculations. But I'm not sure if they'll give you guys calculation because of your. But if you're going to give you calculation, it's going to be a simple calculation. And I'll look at it so simple calculation. I'm not actually praying. I'm just telling you what's. Are you guys scared of calculation? No. Thank you. So let's take this now. Yeah. Calculation doesn't really waste time in chemistry. If you're familiar with some key stuff there, sure you get. That's how I call it. We are still under the nitrogen, oxygen. We know that chlorine bleaches by what? Sulfur by what? Reduction. Okay. Let me just take one more. In production of ammonia, do we need water there? And what's the reason? So that it will not dissolve in the water. So which gas are used for the fountain experiments? Ammonia and what? HCl. Okay, let's take this question. That is used for fountain experiments. That's HCl and what? Ammonia. Look at 2014. I say, we're not writing this. Which of the following halogen is the most reactive? The answer there was fluorine. Okay, so let's write this now. Let's take this question. To a solution of an unknown compound. 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 Comma. A little diluted H2SO4. A little diluted H2SO4 was added with some freshly prepared. The moment you are hearing those things, what are we trying to test for? NO3, Abi. What's the name of that test? Brown ring test. What gas bring that? What compound? NO. Try me now. NO brings the what? The brown ring. Do you get this now? So now we have, so see, this is what happens most times. When you are reading questions, I don't know about you, but the moment you are reading questions, there's a way your brain narrow down to the chapter. And you start to bring out all the information you already know about that concept. So now we have this to a solution of unknown what compound, a little diluted what H2SO4 was added with freshly prepared what FeSO4, right? FeSO4. The brown ring observed after the addition of the stream of that after H2SO4 solution full stop, then you have the brown ring observed after the addition of a stream of conc H2SO4 confirms the presence of. So what are we trying to confirm there? NO3. Option A, Cl minus. Option B, SO3 2 minus. Then option D, option A is Cl minus. Option B is SO3 2 minus. The question, where did you guys stop? The brown ring observed after addition of a stream of concentrated H2SO4 confirms the presence of, then option A, what do you have there? Cl minus. Option B, SO3 2 minus. Then option C, NO3 minus. Then option D, CO3 2 minus. What's the answer there? NO3. Okay, the last task, for you to test for SO4 and SO2, what do we use? Barium what? Chloride. What's the color formed? White precipitate. How do you now differentiate between two of them? Using what? HCl. If it dissolves in HCl, that's what? If it does not dissolve, if it dissolves, any suru, if it dissolves, if it does not dissolve, SO4. CO3, what do we use? Use lime water. When you pass CO2 through CO3, it becomes what? Milky, Abi. That confirms what? CO3. Remember? If you pass CO2 through what's called CO3, that's triazocarbonate, it will now turn to what? Milky. When you pass CO2, that's CO2 through what? Lime. Not lime now. That's CO2 through what? CO3. Any compound that contains CO3 and you pass lime through it, it makes the water turns what? Milky. What's here? Now, one more question, then I'll go to thermodynamics. Then in thermodynamics, we are just looking at probably one or two calculations and some concept there. Yagweli, on eating, which of the following compounds will decompose to the free metal? Which of the following compound? I was surprised now. Ag will not be in the option. Which of the following compounds will decompose to free metals, NO2 and oxygen? Remember, the triazonitrate that will not give out oxygen is what? Ammonium triazonitrate. That's how I call it. On eating, which of the following compound will decompose to free metal, NO2 and oxygen? Option A, Cu into bracket NO3 close bracket 2. Option B, option A, Cu into bracket NO3 close bracket 2. That's copper nitrate. Then option B, you have AuNO3. Then option C, we have Ca into bracket NO3. Then option D, we have NaNO3. So the answer is what? Au what? C is calcium nitrate rather. CaNO3, close bracket 2. So the answer there is going to be what? A. You're on nitrogen now. Remember that to produce nitrogen in the lab, what's the name of the compound we use? NH4NO2. Can you eat the compound directly? And what's the reason? It's explosive. Yeah, just say let's see thermodynamics here. Let's work on thermodynamics. For this one, that's gold nitrate. Now listen, remember, any metal that is below, okay, any metal that is below copper, we always produce the free metal. What's here? Now let's now look at thermodynamics. Now, what's thermodynamics? We say this is the branch of what? Okay, if you cannot eat ammonium nitrate directly, so what do? We have a mixture of what? Salt, What's the mixture of that salt? We can use ammonium chloride, and what? NaNO2. So this will give us what? Ammonium dioxynitrate plus what? NaCl. What's the name of this kind of reaction? Double what? Double? Double replacements. Double replacement. It's a replacement reaction now. It's not decomposing. Yeah, substitution or replacement. Yeah, you are correct. Okay, now, we now said under the thermodynamics, stay under the voice. We say that's a branch of chemistry. No, we have thermochemistry, that talks about the branch of chemistry that talk about reactions and what? Heat what? Involved, What in that class, we talked about the difference between temperature and heat, right? Temperature is measured in what? Units measured in what? Kelvin. Then heat is measured in what? Joules. And we said temperature is the degree of what? Hotness or coldness of a body. Then heat is determined what? The direction of what? Flow, If temperature, if it's going to flow from what? High temperature to what? Lower temperature. But now, we now said there are 3 laws we have to work with, right? The first law of thermodynamics, the second law of thermodynamics, Then we talk about the third law, We're going to finish zeroth law, no. We have the zeroth law, the first law, and the what? N's law too, yeah. Yeah, we talked about the N's law as well. Now, under the first law of thermodynamics, what's the major concept there? Universal energy is constant. That is what? Energy can neither be created nor destroyed. Can be transferred from one form to what? Another. Now, remember we said that under the first law, that's what led us to enthalpy, right? And what is enthalpy used for? To know if a reaction is what? Endothermic or what? Exothermic. When the change in enthalpy is positive, that means the reaction is what? Endothermic. When it is negative, it is what? Exothermic. So endo means that you absorb it from the what? Surrounding before the product are what? Formed. Then exo means that what? It is released to the surrounding alongside with what? Product. That's exothermic, right? We now said a place where a chemical reaction is taking place is known as what? Now, when you have exothermic reaction, know that neutralization is an example of what? Exothermic reaction. Then you have to see, this is where you have to be very careful now. You have to know some reactions. When things or metals dissolve in water, the reaction is what? Exothermic. No, neutralization is exothermic. Then when metals dissolve in water, it's also what? Exothermic. Oh yeah. But when ammonia dissolve in water, it is what? Endothermic. But you have to know some reactions are endo and exo. All combustions are exothermic reaction. Okay, from the energy profile diagram, that's good. Let's look at how to interpret the energy diagram, right? So basically, when you look at that diagram, all you have to look at is the scale. However, it's just Fedumore principle. Now, if you have a reaction like this, and in this, we have reactants here, right? Now, this is the reactants, and here is the product, right? Now, using your Fedumore principle, here is what we call the energy. And this is the part of reaction. Now, when you look at this diagram here, okay, normally if you are looking at your graph, on scale, this value is usually going, right? I'll talking here. Now, this diagram, this value shows that the energy level is increasing. Oh, yeah. Now, when you use your Fedumore principle with your eyes on the board, the reactant has a lower energy here. By the time it gets to the product, what's the energy level? High. So, which means for this reactant to climb this up here, is it going to lose energy or gain energy? Gain. So, let us use, sometimes some of you like money. Let us use Naira to explain. If this is, okay, if this is 200 Naira, now this is the value here, right? And you are looking at this value here to be like 1,000 Naira. Now, for 200 to get to 1,000, what does that involve? It will have to gain what? 800. So, Joe's go, they are saying Naira, and everybody is following. So, when you have 200 Naira, this is the reactant, the energy here. So, for this 200 Naira to get to 1,000, it needs to what? Gain what? 800. That is what? Endothermic. Because it's gaining and it's collecting from someone, right? Now, but in a scenario whereby the product is like at this point here, let's say this is the product here, So if the reactant is here now, and the reactant is what? You want to have 1,000, and you have your product here. Sorry. Yeah, that's the product here, Then the product is now the 200. For 1,000 to be converted to 200, what must happen? You have to lose how much? 800. Then what's the reaction? Exothermic. Okay, so just change the Naira to joules. So if I have 200 joules here, and I have what? 1,000 what? Joules here. You guys, which means the energy of the reactant is what? 1,000. The product is what? 200. So which means this reaction will lose how many? 800. And what's that reaction? Exothermic. So you can just write it down. A reaction is exothermic when the reactant has more energy than the product. A reaction is exothermic a reaction is what? Exothermic when the energy of the reactant is more than the energy of the product, and vice versa.
What was that one? How did that? Oh, Canada.
Are we there? So now let's say so that's the first law. So the first law. Now remember something. Hey, go and of one. We said there's what we call state function, Abby. What are state function represented? They are represented with what? Capital what? Letters, right? And what does that mean? They don't really talk, they don't matter where it happens. Either you start from somewhere, you don't start. The change is always what? The same. So that's the first law. The first law of thermodynamics is used to know if a reaction is what? Endo or what? Exo. Yeah, let's write this question. In the combustion of hydrogen, as shown by the equation below, in the combustion of hydrogen, as shown by the equation below, a reaction that shows the heat involved, what do you call that reaction? A reaction that shows the heat involved, we call it what? Thermochemical reaction. Hey, in the reaction, what's the question? In the combustion of hydrogen, as shown below, in the combustion of hydrogen, as shown below, then write the equation. H2 plus O2 to give H2O. Then you have change in enthalpy minus 298 kilojoules per mole. Now listen, these are possible calculations you can get. These are possible calculations you can get in enthalpy, because this calculation require little or no calculation. Like little, very little calculation. Now, in the combustion of what? Hydrogen, as shown by the what? Equation what? Below. So, have you seen the equation? Calculate the amount of energy evolved by 12 grams of hydrogen. Calculate the amount of energy evolved by 12 grams of what? Hydrogen. Hey, Wobi, see, don't be scared though. When you see questions like this, all you have to do is let your Fejimo principle and your composure be there. What's here? Now, understand this. In this equation, is the equation balanced? No. They will put 2 here, Abi. Balance. Now, hey, okay. Look up. This is why you're having issues with calculation. Psych body statement. It will change the story. When you have an equation like this and you are giving gram, go, Samson, stay with me. When you have an equation and you are giving gram, see, it is what, hey, look at me. It is what the question gives you that will determine your direction of flow. Automatically solve question and you are the one that is determining what you want to do. But in this scenario, the question is one that gives you the mapping. In the setting of this question, we are given the equation. Then what did the question say? Calculate the amount of what? Energy released by what? 12 grams. That 12 grams is the key. Hey, is what? Only kokoro. That's the kokoro we are going to use to open the door. Okay. Now, like I said, what's the major concept here? 12 grams, Abi. Hey, light here because you are solving your own now and you are doing this. You now come back to the equation. The equation is talking about what? Hey, oh, there's one more day. It's talking about what? 12 grams. Come back to this equation. In this equation, you now be focused on what you are given here, which is what? 12 grams. Now, we now look at this. From this standard of equation, we got 1 gram. All your mindset is narrowed down to gram. How many gram of hydrogen is here? 4. I should remember. Which means 4 gram of hydrogen is one that liberates this amount of energy. Minus 298, right? Oh, my mass now, to get answer. 4 gram liberates what? Minus. Oh, okay, don't go to my software. 4 gram liberates what? Minus 298. Okay. Remember in mathematics, we always say that whatever you do to the what? Left hand side, you do to the what? Right hand side. Now, for 4 to turn to 12, what do you think what has happened? You multiply 3. So which means if I multiply this by 3, I have what? 12 gram. Which is what the question is giving me, right? So if 4 gram gave me this value, then 12 gram will also give me what? I'll just, since I multiply this by a factor of 3 to get 12, I'll just multiply this 2 by what? 3. What's that? So I got to multiply. That's what? 894 minus 894 kilojoules per what? No, that's the concept. That's why if you're going to be given any calculation, it's going to be simple calculation in this concept. What? Times 3. Now is the question. Now look at this question. This is the equation we are given, right? Now in the question, we have what? 12 grams. But the question, how many grams liberated is 4 grams, right? So there are many approaches you can use depending on what is convenient for you. So I can say that 4 grams liberates what? 2, that's minus 298. Abi? Now, how many grams are we given? So now that therefore 12 grams will liberate what? X. Then what do? You cross multiply me. So X now becomes what? 12 times minus 298 divided by 4. 4 here 1, 4 here, 3. So is this same as what? 3 times minus what? 298. And that's what we get as what? 894 kilojoules per what? Mole. Because really, it's more applicable if you are doing WAEC and you need to show working. But you tell me, just know the factor. Properly. Give you like 13 grams. That is when this will be very applicable. But most times, UTME give you stuff that are easy to work with. What's here? How do you calculate what? The heat of solution. It's the same thing. Depends on what you are giving. I think we'll get one more question on that. Yes, cycling. Portion of ethanol. So if you're doing, learn to work with the fast calculation. What's here? Just look at it. Let's assume that we are looking for what value of energy is liberated by, say, 24 grams. So what do you multiply this with? That's a factor of what? 6. Because 4 times 6 will give us what? 24. That's how I call it. Calculate the amount of energy liberated. Okay, in the combustion of ethanol, when the carbon undergo combustion, what are the product form? CO2 and what? Water. So if a student is reading with candle, what is likely to do the gas in that room? CO2 and what? Water. That's how I call it. What's the first organic compound to be produced in the lab? Urea. It must stop, you know. In the combustion of what? Ethanol, in the combustion of what? Ethanol, we have minus 789 minus 789 minus 789 minus 789 kilojoules per mole of heat is released. Of heat is what? Released. Calculate the amount of energy. Calculate the amount of energy released by 0.1 mole of ethanol. Calculate the amount of energy released by 0.1 mole of what? Ethanol. Then this is the equation. The equation is ethanol is C2H5, right? OH. If this undergoes combustion, the product will be what? CO2 plus what? H2O. So if I put 2 here for carbon, right? I think hydrogen is 6, Abi. Then what is the total we have here now? Total oxygen is what here now? 2 times 2, 4, Abi. 7, Abi. So we can put 3 here, right? Is the equation balanced? Okay. And what's the amount of energy liberated? Minus what? 789 kilojoules per what? Mole. Now, okay, hey, listen. I'm telling you that most of the calculations you'll be coming across, they are calculations that the answers are smiling at you. What is the amount of energy released here? Minus 789 kilojoules per what? Mole. Per mole. Which means 1 mole of this compound, 1 mole of C2H5OH is one that releases what? Minus 789. That's the meaning of this 789 kilojoules per mole. The application is what? 1 mole of what? C2H5OH releases what? Minus 789. Now, can you question? Solomon Ojo and Mumi Not Akimbola. I think your attention is near downstairs. Now, Mawon 1 mole. Go. Calculations that were not easy. 1 mole of this produce what? We're looking for what? The amount of energy produced by what? 0.1 mole. There is no calculation on Moyami. 0.1. From here, this is 1, Ami. If I put my decimal place back once, what do I get? 0.what? So what? Minus 78.9. That's all. There's no These are simple calculations we are expecting because we produce this. So for 0.1, because for you to have 0.1 from 1, you just move your decimal place back by what? A factor of 1. So just move this one to you have what? Minus 78.9 kilojoules per watt. No. That is answer for 2 questions. See. Make sure you get everything. Marfo. And mind you, if you are solving, and someone is solving beside you, call him. Funny boots. Yes, I question. Combustion of ethanol. Are you still writing? Like I said, culture first. But most of them don't really have in the combustion of ethanol. Sorry, that's ethanol. In the combustion of use propane. In the combustion of propane is what? C3H8. You don't understand. That here I don't understand. Okay. In the combustion of propane, in the combustion of what? Propane. In the combustion of propane, we have minus 1,130 kilojoules. In the combustion of propane, minus 1,130 joules is liberated. Yeah, kilojoules. In the combustion of propane, minus 1,130 watts kilojoules is liberated. So we have calculate. So you have calculate the amount of heat. Calculate the amount of heat liberated. Calculate the amount of heat liberated by 4 gram. Calculate the amount of heat liberated by 4.4 gram of propane. The amount of heat liberated by 4.4 gram of propane. Make sure you are working on. It is not possible in a row. In your common. Adura Bilo, Solomon Ojo, Mumunat Akimbola. Your question is needed downstairs, please. Have someone gotten the answer? So what was the answer there? Minus what? 113. What's here? That's as that. Now write this question. Someone has this solving. Okay, sorry. Well, Lema Bilotin Binu, be smiling. If that true, help someone beside you. More hold the knowledge. Are sulfate soluble in water? Most of them are soluble, right? Except for some of group 2, right? What about SO3? Are they soluble? I know that she saw. Was it this class? SO3, are they soluble? SO3 are insoluble except the group 1. More rules of solubility. So I pray you guys come out with powerful testimony. Okay. I think some of us want us to do the correction, Abi. And you can start run it together. Then you just do one more. Then I go to the second law of thermodynamics. They gives energy. I know we don't have issues there. That's like well. What's the compound? Propanol, Abi? Propane. That's C3H8. When this undergo combustion, it will give us what? CO2 plus what? H2, Abi. What's the amount of energy liberated? Minus 1130 kilojoules per watt. Mole. Over. And we are now looking for the energy released by what? 4 gram. Oh yeah. So calculate the molar mass of this. So the molar mass is what? 44. So which means automatically 44 gram of this is one that liberated what? Minus 1,130 kilojoules per watt mole. Have you now? So now we are now looking for energy released by what? 4.4. Is the answer not looking at you? This is 44, I mean. So you want to get the amount of energy released by what? 4.4 gram. 44 to 4.4. The point move how many times? 1. So what happened to this? Who called the first answer for me? Is that what you guys said? That's what? Minus 113 kilojoules per what? Mole. Check the answer here. Yeah, take this question. Then we'll now go to entropy. Remember that the second law of thermodynamics says that what? The universe move towards what? Disorderliness. And the degree of disorderliness is what we call what? Entropy. But we're saying later what? S. So if the thing gives energy is 0, what does that mean? The system is at what? Equilibrium. If it is negative, spontaneous. Positive, non-spontaneous. What's the relationship between the three? Change in what gives energy is equals what? Change in enthalpy minus temperature change in what? S. Remember that this change in S must always convert it to what? Kilojoules to rhyme with this what? Change in enthalpy. And the temperature must be in what? Kelvin. The absolute what? Temperature. Let's see here. Okay, that's on that. So let's take this last question. Arafat. Your attention is needed downstairs. Arafat. Let's take this last question under enthalpy. What's the formula for calculating heat gain or heat loss? MC what? Theta. That's same thing used for dissolution. So if you are giving a question on dissolution can either be endothermic or exothermic. Heat of solution, yeah. It can either be endothermic or exothermic, depending on the nature. Under the, okay, let's write this now. Heat of solution, under heat of solution, just one. Heat of solution, well, the amount of heat. So don't write that. Let's put it this way. Let's write this way. When calcium carbide is dissolved in water, when calcium carbide is used for the production of which components? Well, ethine. So when calcium carbide is dissolved in water, the water. The temperature of the water increases by 14 Kelvin. When calcium carbide is dissolved in water, the temperature of the water increases by 14 Kelvin. Comma. If the volume of the water is, so I mean the mass. If the mass of the water, if the mass of the water is 100 gram, if the mass of the water is what? 100 what? Gram. Calculate the heat change of dissolution of calcium carbide. Calculate the heat change of the dissolution of calcium carbide. You know, when calcium carbide, what's the formula again? CaC2 dissolves in water, right? So what is produced? C2H2 and what? Calcium oxide, right? Okay, the equation is balanced like that. So now, from that question, we are not giving the amount of energy released, Abby. The amount. No, we are not giving that maybe it's 1,000 kilojoules per mole or something. But we are giving that it increased the temperature of water by what? So which means change in temperature is equals to what? 14 what? Kelvin, right? What's the mass of the water? 100 gram, Abby. What's the specific heat capacity of water? That's 4.2 kilojoules, right? Okay. So now from this place, I know that heat gain. Can you push that? Can you hand reach there to push that mic? Yeah, thank you. Okay, thank you. No, no, you just use the mass direct like that. They have like you're given a mass. Okay, we can get one of the questions. So now in this case now, no, we have the heat gained by water equals what? MC change what? Theta. So what's the mass here? 100 multiplied by what? Okay, let's take this to 4,200, right? That would be joules, right? So that would be 100 multiplied by what? What's the specific heat capacity? 4,200 and what? 14. So what's the answer we're going to get here? Convert it, what's it called? 5,300 and, are you sure? 588. That's a large value. Really? It's in joules, right? Let's say, can we just change directly like 4.2? We multiply by 4.2, what do we have? 100 times 4.2 times 14. 800 and what? 80. That would be kilojoules, right? This is joules, right? So if you want to convert to kilojoules, what would that give us? 5.88 kilojoules, right? So that will now be the amount of heat liberated by that. So on one basic concept now, then I think I'll just talk last on acid, base, and salts. What are the name of the three scientists that talk about acid? Brusted and Laurie and Lewis. Could you already seen in gram? But you guys convert this. Now you have the 4.2 to be in what? That's in kilojoules, right? Okay, because it will still give you the same thing. Have you solved that? There's no need to come. We should have the same answer anyway. It's still going to arrive at the same thing. Now, let's just take this now. For acid, now we said there are how many scientists that talk about definition? 3. Arrhenius, Lewis, and Brustel-Lowry. Now, according to yeah, we'll come back to that. Let me quickly round up on this. The conversion, I mean, I'm not pass here. Now, no, we have 3 sciences, right? This question, this question. I think we use that to explain everything. I think this one will be this 4.12 is already in kilojoules. This is already in kilojoules per mole normally. Then the mass will be what? Kilogram, without be 0.1, right? Okay, but you know, this question come often. Let's take this question that is more of UTM stuff. We have this question. 1.1 gram of calcium chloride. 1.1 gram of calcium chloride. 1.1 gram of calcium chloride. Oh, the 1.1 gram of calcium chloride dissolves in 50 centimeter cube. I think I use mass for you guys, Abby. Dissolved in 50 centimeter cube. 1.1 gram of calcium chloride dissolved in what? 50 centimeter cube of water caused a rise in temperature of 3.4 degrees Celsius. 1.1 gram of calcium chloride dissolved in 50 centimeter cube of water caused a rise in temperature of 3.4 degrees Celsius. A rise in temperature of 3.4 degrees Celsius. Then have this now. The heat of reaction for CaCl2, the heat of reaction for CaCl2 in kilojoules per mole, in kilojoules. I'm too fast. Let's take that again. 1.1 gram of CaCl2. 1.1 gram of CaCl2 dissolved in 50 centimeter cube of water. These are 1991 questions. So probably you might not get something related to this, but who knows here. 1.1 gram of CaCl2 dissolved in 50 centimeter cube of water caused a rise in temperature of 3.4. caused a rise in temperature of what? 3.4. The heat of reaction for CaCl2 in kilojoules per mole is option A, minus 71.1. The heat of reaction for CaCl2 in kilojoules per mole, that's kg per mole, is option A, minus 71.1. Option B, minus 4.18. Option B, minus 4.18. Option C, plus 17.1. Plus 17.1. Then option D is plus 110.0. Then you have in bracket Ca equals to 40, Cl equals to 35.5. Then here we are given that the specific heat capacity of water is 4.18 kilojoules, I think, per mole. That's 4.18 kilojoules per mole. Now, when you look at that question now, let's look at what we are given. We are given the mass of CaCl2, right? What's the mass of CaCl2 used? That's 1.1 gram, I mean. What's the volume of the water? That's equals to 50, which is the same thing as the mass we are using, right? Then we are given a change in temperature. So what's the change in theta there? 3.4 degree what? Celsius, right? Okay. Then we are given specific heat capacity, right? That's 4.12, right? I think 18 from the question. Now, can we calculate the heat? So what's going to be the heat gain? Heat gain is equal to what? MC what? Theta. Which is going to be what? 50 multiplied by what? 4.1218 rather. Multiplied by what? 3.4. I mean, what did you get? 710.6. This is in joules, right? Yeah, the volume is equivalent to the mass as well, right? So that volume is equal to 50. So when you have 50 centimeter cube, it's equivalent to what? 50 gram as well. I think we have solved this before in the class now. So when you have this now, so what do you have here? 50 multiplied by this, that gives us what? This is 7. Are we saying what? No. We're using this directly. Just use it that because that's the only thing that can meet up with that question. Are you going to cancel what? If you convert this to Kelvin, what will be the value here? That will be 276.4. Okay, let's take this solution here. Now you have the mass, right? That's what? 50 times what? 276.4 multiplied by what? 4.18. What's the final answer you get here? You have what here? 57767.6, right? This is the value you have here. Okay. Now we're getting somewhere now. So you understand the concept. That was like 999 question. They didn't really focus on conversion. Now, if you convert this to kilojoules, what is this going to give us? Is this in kilojoules already? So we convert, that will give us what? 0.716. That is 0.7. That's kilojoules per what? Mole. Oh, yeah. Now, this value is released by what? 1.1 gram. Understand that 1.1 gram is what released this. Now, what is the molar mass of CaCl2? So the molar mass of CaCl2 is equivalent to what? 111 gram per what? Mole. So now go back to this question. 1.1 release what? 0.7106 kilojoules, right? For 111 gram, we release what? Every time your decimal place move, 1, 2. So this one also move how many times? 1, 2. That gives us what? 71.606 kilojoules per what? Mole. So what's your answer there? Option what? C. Now that's the nearest option now. And that's approximate it. Do you have it there? That's option what? That's approximately what? 71 point what? 1 kilojoules per what? Mole. So note that the question, the conversion was not done there. So it was used directly to solve. So what I'm saying is this, be guided by your options. So, but if you use it directly, if you convert to Kelvin, you will have an option in the what? Question. Yeah, but in some cases, they give you directly in Kelvin. So you get some question like there's some question that give you directly in what? In Kelvin. So which means this reaction, is it endo or exo? The answer is what? Endo. Because it's what? Positive, right? Sorry? The option is what? Okay, the option is what? Minus 71 point. I will give you minus from the initial onset. Okay, so the reason why it is minus, no, what do you have back here? 71.5. Well, when CaCO2 dissolve in water, the reaction is what? Exothermic. The solution, right? Just write notes. The solution of CaCO2 is exothermic. The solution of CaCO2 is exothermic. The solution of CaCO2 is exothermic. I think it was in this year series that will be specified. But here you are expected to know that the solution of CaCO2 is what? Exothermic. The solution of what? Salt in water, yeah, it's also exothermic, but slightly. Some exothermic reactions are not really noticeable because the change in temperature might be very what? Minute. Okay, let's take this now. But when it comes to calculation, hardly will you see this kind of calculations again because you are not using scientific calculator. Most of the calculations you have here are just straightforward. Some of them, just looking at the question, you can pick your answers directly. So 50 centimeter cube is equivalent to what? 50 what? Gram. Can I study this question? The last one we're doing now is on acid. Are you guys writing? Hey. Okay. Yes, I'm just trying to see if I can cover as many as possible.
Just people. Why?
Okay, let's take this now. Now, just going to look at acid, base, and salt now, just very few. No, there are three scientists that talk about the definition of acid. Now, before those scientists, what was the initial definition of acid? Acid was sour taste, and they are corrosive. Now, what about base? Bitter taste. So if you have been, when acid contains large amounts of water, what do you call it? Dilute. When it contains large amount of water, what do you call it? Punk. What was the formula for dilution? I'll take this question. That was right. 18.5 centimeter cube of H2SO4. Remember that apart from that, we also have CaVa for neutralization, right? 0.5 centimeter cube of H2SO4 is required. 18.5 centimeter cube of H2SO4. 18.5 centimeter cube of H2SO4 is required to neutralize 18.5 centimeter cube of H2SO4 is required to neutralize 25 centimeter cube of Na2CO3 is required to neutralize 25 centimeter cube of Na2CO3 with a concentration of 0.125 mole per dm cube with a concentration of 0.125 mole per dm cube. Full stop. Calculate the mass concentration of H2SO4. Calculate the mass concentration of H2SO4. Then open in brackets, H2SO4 is equals to 98 gram per mole. So you are given the volume of the acid. Calculate the concentration of the mass concentration of H2SO4. Yeah, mass concentration. Please note, we are not using C1V1. What are we using there? CaVa over Cb Vb equals to Na over Nb. Then note, you should be able to write the balance equation. When acid reacts with thiazocarbonate, what is liberated? CO2, salt, and water. Sorry, come over. Someone is true at the back there. CO2, salt, and water. So identify the salt liberated. So identify your C, identify your CB, your VB. Know what you are looking for. Design a plan. Alpha. So what did you get? I'm waiting. I'm just asking some things. So you first get the concentration in mole per dm cube, right? And after that, you now get the concentration in what? Gram per dm cube. So for some of you that are still struggling with the equation, that's H2SO4 plus what's the salt again? Na2CO3. So this will give us what? Na2SO4 plus H2O plus CO2. Is the equation balanced? Yes. So what's our Na? 1. Nb? 1. What's our Va? 18.5. What's our Vb? 25. What's our Ca? Unknown. What's our Cb? 0.125. So put that in the formula, then you can get your value. Okay, can we proceed now? So what's the answer? I don't care. 16.5 gram per what? dm cube. 16.5 gram per dm cube. Note, the only thing that can limit you in equation like this is if you don't know how to write the balance equation. That's why in acid, base, and salt, we gave you the concept. Acid reacts with base to form what? Salt and water. If it's thiazocarbonate, you have what? Salt, water, and carbon 4 oxide. Be able to identify the salt. Now look at this question on the board. Now looking at this particular graph here, what will be the best indicator to use here? So the answer was any indicator. What's the reason? Strong acid, strong base. Now write this question again. And I didn't to scare this one again. You have to understand the graph now. That's how I call it. Which of the following will have the highest conductivity? Which of the following will have the highest conductivity? Sorry. Monsurat Akindia and Victoria Oluwa Dari. Sorry, hello. They didn't ask you to call Mr. Victor too. Maybe someone is waiting for me to come and carry me. It's so interesting. When you have which of the following? Which of the following? Bye bye, we'll miss you. Which of the following, Shamaka, which of the following will have the highest conductivity? Which of the following? Oh, go take. Sorry, do you need to do correction on that calculation? Just say help and come. Hello. From that solution, what's our V? No, C V over what? CB VB equals what? NA over what? NB. We are looking for CA here, right? We are looking for what? CA. So we can make CA the story of the formula, right? So CA is equals to what? CB VB NA over what? VA NB. If you don't know how we got this, hold someone beside you there. So what's our CB there? 0.125, Abby, times what's our VB? 25. What's our NA? 1. Divided by VA is what? 18.5 times 1. So when you divide this, what do you get? 0.16. 0.1689, right? Two decimal place. No, I think the question is in 3 decimal place. 0.169. That's mole per what? dm cube, Abby. Now this is CA. That's your CA, right? In mole per dm cube. Now, how do you now convert this to gram per dm cube? Okay. So this means concentration in gram per dm cube, right? Is equals what? Concentration in mole per dm cube times what? Molar mass. So it's 0.169 times what? 98. So what do we get? 16.56. Yes. For those of you in that frequency, let's write this down. So which of the following have the highest conductivity? Which of the following have the highest conductivity? Which of the following have the highest conductivity? Option A. Option A, 0.5 mole of HCl. Option A, 0.5 mole per dm cube, rather. 0.5 mole per dm cube of HCl. 0.5 mole per dm cube of HCl. Option B, 2.0 mole per dm cube of HCl. 2.0 mole per dm cube. Mole per dm cube of HCl. Option C, 0.5 mole of ethanoic acid. 0.5 mole of ethanoic acid. Yeah, mole per dm cube, rather, sorry. 0.5 mole per dm cube of ethanoic acid. Then option D, we have 2.0 mole of ethanoic acid. Remember I told you that your syllabus said that student must be able to what? Analyze the... I gave you guys yesterday, I mean. So what's the answer there? That's 2.0 mole per dm of what? HCl. Promise.
Good morning, class. Good morning, class. Please, for those of you that have exam tomorrow, and those of you, many of you in the hostel, please, the hostel students, especially for 6:30 a.m. in the morning, please, I would like to see you guys after the lecture today. Those for 6:30 a.m. tomorrow. And if your exam is 6:30 a.m. on Monday, in any of the hostel, either the boys' hostel, the girls' hostel, please, I would like to also see you today. It's very, very important. Your exam is 6:30 a.m. in the morning, tomorrow and Monday. Please, I want to see you. Thank you.
Let's do Saturday and Monday first. They are not coming again. Why are we not coming? They're not coming again. Okay, Johnny. Okay, sorry. So the last one I'll be talking about now. You understand that last one? The principle there is that the concentration, the more the conductivity.
So when you look at the option now, how many acid do we have there? We have two acid, Abi, which is HCl and what? Ethanoic, Abi. Yeah, which of them is the strong acid there? HCl. So now, no, so HCl is stronger than ethanoic, right? Look at the concentration of the HCl given. We have 0.5 and we have what? 2.0. So the one that have the highest concentration will be what? We have the highest conductivity. So here. So the higher the concentration, the more the substance can work. Speaking of alloy, mixture of what? Metals. So for the last time now, what are the components you find in duralumin? So how many percent is aluminum? 95. What about copper? Manganese. Then magnesium, 0.5. Which alloy is a combination of iron and nickel? Which one is palm alloy? Iron and what? Nickel. What about brass? Copper and zinc. What about bronze? The type that is used in the typing industry. What's the alloy you have there? Lead, tin, and what? Antimony. Type metal. You have lead, tin, and antimony. Those are alloys you have there. What's here? Then which metals can give white precipitate with sodium hydroxide? Aluminium, zinc, lead, and calcium. So these four can give what? White precipitate. Which of them will not dissolve in excess in sodium hydroxide? Calcium, Abi. Then which of them will dissolve in excess? These three, Abi. Which of them, which metal, which ion produce a golden yellow flame? Brick red. Lilac. When you view the calcium through when you view through what? Blue glass, it appears what? Green. That confirms what? In the extraction of sodium, aluminum, and which of them is the most expensive? The most expensive is what? Aluminum. In solvent process, the only waste product what? CO what? CO2. Thank you very much for your time. Have a wonderful time.
It's coming on Tuesday. Hello, hello. Victor Precious, your mom is downstairs.
Victor Precious, your mom is downstairs.
Victor Precious, your mom is downstairs.
Okay, we got to do some physics summary. Okay, so we want to quickly run through the syllabus now for like 1 hour commentary, non-stop commentary. Your work is just to listen. You don't need to do any writing because we've done that. You just to review the entire syllabus. And I won't want anybody to distract me, especially at the front. So please, if you're going to sit down at the front, come and sit down before I start talking. Nobody sit or pass here when I'm talking. I want to talk for almost an hour non-stop, running through the entire syllabus. So it's just for you to review all the things we've done. So we're going to pass the front here, or you sit. Do that now. Once I start, nobody pass here. So our first topic was measurement and unit, and we explained that in physics, when you are measuring, it's very important for you to ensure that you measure with accuracy And then there are some basic things you have to do. Number one, in measuring length, for example, you must avoid error to parallax, and that can be done by ensuring that you place your eyes vertically above what you are trying to measure. Very important. And for measuring length, we have three major fundamental instruments. One is the micrometer screw gauge. That one gives us the highest precision ever. Then we have the vernier caliper, we have the nearer precision to that one. And then we have the meter. For the meter rule, the smallest division of graduation is 1 millimeter, while the accuracy measurement is half of that 1 millimeter, which is 0.5 millimeter. For the vernier caliper, we have 0.1 millimeter, while for the micrometer screw gauge, we have 0.01 millimeter. Measurement accuracy for all of them is always half of the smallest graduation. We're also told again that in measuring those materials, the one they use, they always ask every time, talking about the micrometer screw gauge, it's all about the thickness of a wire or the thickness of a thin sheet of paper. The vernier caliper is majorly for Jamb, NECO, and WAEC, is for measuring diameter of a test tube. And then I've said it exactly before that we can have two major forms of error. One is random, one is systemic error. Systemic error is the one that is due to the faulty instrument, the one you cannot control. Faulty instrument, changes in weather condition, all this can bring about systemic error. For example, you want to do an experiment on light and then it became cloudy immediately, then it's going to affect your result. That's systematic error or systemic error. Or another thing again is you have a faulty instrument. For example, you want to do practicals on titration, and then the burette refuses to close, the tap refuses to close when you are trying to stop it. That's systemic. Random error is the one that is caused by the experimenter. The student himself generates a random error. And that random error can be minimized by repeating the experiment many times and then taking the average result. From then, we spoke about fundamental and derived unit and quantity. Fundamental quantity, majorly there are 7. The length, the mass, and the time. And then we also have the electric current, we have temperature, also amount of substance, and then luminous intensity. There are 7 of them. And then their units are called fundamental units. For length, we have meter. For electric current, we have amperes. For mass, we have kilogram. For time, we have second. For luminous intensity, we have candela. And of course, amount of